For question 2, you're supposed to just figure out which statement is describing what's happening when a system is in resonance. So first and foremost, right, we need to understand, right, resonance, right, this term is talking about a particular phenomenon that we observe, right, when the system, right, is undergoing forced oscillation. Okay, so there's always, right, a driver and there's a driven. Okay, the driven is the um, mechanical system. So we want to see, right, when the driver, right, apply different frequency, how does the driven, which is the mechanical system here, respond to it. So the y-axis, right, is the driven's amplitude. So this graph, right, is quite easy. You already know it quite well. So here, right, this particular peak, okay, this one you call it resonant frequency. Okay, and resonant frequency, right, at low degree of damping will happen to be the natural frequency. So what's happening here, right, is that the object, right, is being forced to oscillate at various frequency according to the driver's fancy, right. So at different frequency, right, the object respond differently to it. At some frequency, it actually doesn't um, takes up the driver's work. Okay, and its energy, right, doesn't increase, right, in the way that's ideal. Okay, so it simply, right, end up having an amplitude that is lackluster. But at a particular frequency, right, it actually respond very well, and that frequency, right, is close to its natural frequency. Okay, so the natural frequency of the object, right, is the frequency that if you set it into free oscillation, you will actually prefer to oscillate at that frequency. So that's the frequency it prefers. So if you try to apply a driving force to it at the same frequency as the object, then, right, it will uptake the energy at the most efficient rate, and hence, right, display the maximum degree of amplitude. Okay, so the correct statement is option D.